Hi, it's Alex with Rodometry, and today I wanted to talk to you a bit about what we're working on right now. So this video isn't directly applicable to our current product, but if you're interested in a customized version of our software to detect a different type of object or something like that, you might find this video interesting. Okay, so starting from the top, what do? We make software that counts traffic in video. So if you just take a look at the background here, basically our software is tracking these objects and counting them. Okay, so how does it do that? Our current version of software right now, it looks at every frame individually and it identifies vehicles in those frames. And in order to do that, it uses a technology called YOLO, which is a type of a neural network. And any neural network needs a training set. So a training set is a whole bunch of individual labeled images that people have gone through by hand, saying, here's a car, here's a truck, here's a person, and you do that for thousands and thousands of images, and that's your training set. So this website, Image Class, is a website I built for this purpose. I use it to upload large image sets containing mostly traffic data, and then I hire people to tag that for me. And this gives me a customized neural network for tracking traffic, which is adapted to the specific videos that I've trained it on. So this website is not really an external product. It's more of an internal tool that we use for building our main product. Okay, so this is the older version, Image Class, and this works on individual images. So I'll upload a set of 1,000 images, and people will go through each image separately, like you see here, and they'll tag each object in that image one at a time. Okay, so what's the problem with that? The issue is I'm counting traffic in video, and it can be difficult to identify vehicles using only a single frame of traffic. So for example, in this picture, there's a column of traffic here in the background, but it can actually be kind of hard to tell exactly how many vehicles are there in a static frame, especially if it's lower resolution. So video has a lot more information than single frames. If you watch a video, you can identify movement much more easily than you can identify individual objects. So for example, if you see a pedestrian in a low resolution video, it'll be a lot more clear that it's a pedestrian in a segment of video compared to a single frame. So for our next release, we want to be using that extra information, combining the frames, and not just detecting objects on a single frame basis. Okay, so what are we using for that? I'm building this new website, framelinker, which is kind of like an upgrade to Image Class. And let me just show you how that works. Okay, so we've got a few frames shown here, and these ones have already been tagged, but let me just go a little bit further ahead. Okay, so now we've got a few frames that have not been tagged. Alright, so let's just select the type of object we're tagging, which will be a truck, let's say, and we'll just tag a couple of these trucks. Okay, so the big difference you'll see here is that we're actually tagging objects in, we can see multiple frames at a single time, and the big difference is not just that you're tagging objects, but that we'll actually be linking them from frame to frame. So this indicates that this bus is the same as this object, and then we'll link this to this, and we'll link this to this, and so on. So you would carry on tagging and linking all of the visible objects in each frame. And the purpose of this is to give us a training set that identifies not only objects in individual frames, but like I said earlier, multiple frames, and it links them from frame to frame so that our neural network can learn not only how to identify vehicles in individual frames, but how to track them through frames. And this is should give us better performance than our current method, which only uses a neural network for individual frames and uses separate methods for combining the frames. So our method right now, it works for very clean data where you have vehicles that are visible for good periods of time, not too much interference, reasonable sizes, but we want our software to really work for those strange videos where you have vehicles off in the distance, or you have vehicles blocking each other from view for a long time, or maybe you have some complex movement patterns, or you have a very wide range of object sizes. There's a whole bunch of cases that aren't really dealt with very well by our current release. So we want to make sure our software works out of the box for as many situations as possible, and this framelinker tool is going to be one of the ways we achieve that. There's also some possibility that we'll try to spin off this framelinker tool as a separate product. And that would be helpful for people who are building their own tools for tracking other types of objects in video. So, for example, if you're tracking sports players and you want to follow the ball, or if you're tracking some type of machinery on a site and you want to keep track of that, this type of tool, framelinker, could be helpful for building a training set for all types of situations. Okay, thanks. That's all for now.